Welcome to the Tech Talk on Universal Alerting. My name is David Millis, and I'm a principal strategist at Splunk. I'm going to tell you about universal alerting and how it can help you in your AIOps journey. And then I'll show you how it works. AIOps, the new way of handling monitoring and alerting, is critical for both observability and traditional IT operations, but it can be difficult to put together sometimes. Universal alerting provides a kinder, gentler path for implementing AIOps, specifically a better way to wrangle those alert sources such as Splunk Infrastructure Monitor, Nagios, SolarWinds, maybe even BazookaNet Manager. This allows all alert sources to be easily integrated and correlated, both Splunk and non-Splunk. Even weird alert sources such as change control events or weather or whatever. And will still reduce the noise, provide service context, and improve actionability. Everything you need to make your ops far more effective. Universal alerting includes three major concepts. First, we're going to use a new naming standard for alert fields. And yes, it is part of the Splunk Common Information Model. Second, we're going to normalize a few fields for that alert source as good old-fashioned core Splunk search time knowledge objects. And finally, we'll let the new universal content within IT service intelligence do the heavy lifting, finding those normalized alerts, then onboarding, grooming, deduplicating, correlating, and intelligently grouping them as episodes. And by the way, those universal components will work across all such alerts, regardless of origin. Let's hear it for reusability. If you're an implementer, the first thing you'll do is install the updated monitoring and alerting content pack for ITSI. And then for that alert source, such as Nagios or SolarWinds, we'll identify some normalized fields based on our new Common Information Model, ITSI normalization standard. And by the way, we only need 4 fields for this to work. Next, we'll create those normalized fields as core Splunk search time knowledge objects. To do this, we can either use the existing core Splunk GUI or our new fabulous Splunk app, Conf Editor, which makes this process much easier and faster. And that's it. Our normalized alerts will now be auto-magically brought into ITSI, thoughtfully correlated and grouped into episodes. And you, the implementer, didn't have to configure ITSI at all. It really is quite cool, and it works like a dream. Would you like to see this in action? Of course you would.
Hi, my name is David Millis, and I'm going to demonstrate universal alerting to show how quickly and easily we can onboard raw alert sources into ITSI. We're starting here with a pristine installation of ITSI, and my raw alerts from Nagios and SolarWinds are already in core Splunk, but not ITSI. And I've installed the content pack for monitoring and alerting for ITSI, as well as the Splunk app Conf Editor. So here we go. We've got ITSI without any alerts. Let's see how quickly we can bring in a new alert source and get it singing and dancing in ITSI. How about Nagios host availability alerts? These are fairly common with our customers, and it's basically just Nagios pinging devices and spewing up or down alerts. This is what they look like. Based on these native Nagios fields, we're going to create a few more normalized field definitions for this to work. We can add some other field definitions later to make it even better if we want to. Here are the 4 required fields that we're going to use. SRC is the object that this alert is about, usually a host or device. Signature is the name of the alert, such as host availability or CPU too high or similar. Vendor severity is the vendor-specific severity or importance of this alert in the vendor's own words. And severity ID is the translation of vendor severity into the ITSI specific severity values 1 through 6. We can also add some optional fields if we care to. Some alerts will have a subcomponent field, but these Nagios alerts don't. We'll also use ITSI include and set it to false while we're testing. And we'll include description and app since they're so handy to use. So, which fields can we use for our normalizations? The Nagios field source host is a good choice for our SRC field. For signature, we're going to use a static value of check host availability, since all of these Nagios alerts are the same type of alert. For vendor severity, the host state field works nicely for us with its values of up and down. And for severity ID, we'll need to translate those up-down values to ITSI severities. Down will be an ITSI critical, or 6, and up will be an ITSI normal, or 2. So we can add these fields temporarily to our search right here, just to make sure that our syntax is correct. And here's our fields. SRC, we've got our static value and signature, vendor severity, and we're using a case statement to turn that vendor severity into ITSI severities 2 or 6. So we can put these evals and extractions into a handy cheat sheet to make it easier to create the knowledge objects. And to actually create those knowledge objects, we're going to use a fabulous new Splunk app called Conf Editor. Make sure that you're using the Normalized Fields tab within the app. So let's create some normalized fields. From our cheat sheet, we've written down the index is ITSI demo. We can use a source or a source type. In this case, the source type is Nagios host perf. Destination app, we're going to install this in. And by the way, it's going into a props.conf file. I recommend we put it into the ITSI app and that we go for a global setting for sharing. We can sanity check and make sure that we've got the right index and source type by clicking on that Search Fields button. So after we provided the basics, let's go after the fields we want. You have to spell these words correctly. During the process of creating these knowledge objects, it's a good idea to set ITSI include to false. So we're going to save that. And as we create these knowledge objects, they will start showing up in new searches when we run them. So Let's rerun our previous search and see if our new field shows up. And indeed it does. So let's go after the rest of these fields. We're going to create SRC based on source host. We're going to use a signature with a static value of check host availability. We've got vendor severity we're going to create, and some others. Our mandatory fields will show up here at the top, those required fields. And as we use them, they disappear off the list. Signature is a static value. Does anyone remember what the vendor severity field is? Fortunately, I remember. And finally, for that severity ID field, we're going to use this clever case statement that we created. In addition to those required fields, let's add a couple more. The description field is really handy. This is going to be based on the Nagios reason field. And it's nice to have a app identifier to tell us who is generating these alerts. So we're going to call this Nagios host. Now, this tool, in addition to allowing us to create new field definitions, will also allow us to modify existing ones. For example, I'm going to change ITSI include back to true. It also allows us to create arbitrary field definitions that aren't on the list. Let's create a new field called demo person, which of course is me. There we go. And let's see how this is going. Now, in a large Splunk installation, it can sometimes take up to several minutes to push out these knowledge objects at the time that they're created. Let's see how we're doing here. Appears that my fields are showing up here. We've got SRC. My signature value is here. Vendor severity. Most importantly, our severity ID is there. And we've even got a description. And our ITSI field is now set to true. So now that we have a normalized alert source, ITSI will automatically find these new alerts from the source via the universal correlation search, which runs every 60 seconds. The universal correlation search also does some other things that are completely new for ITSI, such as alarm state deduplication over the last hour's worth of alerts, as well as backfill over that last hour to pick up any alerts that we might have missed. Let's see if we have any new notable events coming in. And here we go. Let's click on one of these. As you can see, our fields are all in their places, including our drill down search. We have additional drill downs that we could have added for this as well. So far, so good. But the really useful thing in ITSI is not necessarily the notable events. It's grouping those notable events into episodes. The content pack for monitoring and alerting contains several pre-configured aggregation policies, which will work with all of your universal normalized alerts. Let's look and see what we've got. We in fact have got a variety of things coming in right now. I'm looking to see which one I want to grab. I want to rerun this. There we go. One of the simplest episodes is by alarm. This is a very simple but useful episode grouping. These alerts are grouped into alarms which have a life cycle of their own. So an active alarm, in this case, starts with a down alert for a particular host. And later, if an up alert is received for this host, the alarm clears and turns green, and it closes the entire episode. We also, let me show you some others. We also have by source. Here we go. Source, of course, is going to show us all of the alarms coming in for this particular host or cloud object. One of the most important things that we can have is the by ITSI service, which of course is going to show us alarms coming in from all the different monitoring systems that may be affecting a particular ITSI service. Most importantly, it's going to show us whether these alarms are currently active, like this one, or if they've already cleared. This is particularly useful for understanding and prioritizing what we should be working on right now. So the point here is to make alerts useful for the poor bastards in IT operations. The Network Operations Center, Site Reliability Engineers, Tier 2 support, and others. Universal alerting provides a solid, reusable foundation for bringing in any alert source in a simple, efficient manner, quickly. Alerts are handled and correlated in a consistent way, requiring minimal ITSI configuration. And although the implementer does need to know some basics about creating core Splunk knowledge objects, they do not need to be an ITSI brain surgeon. So it took us a little less than 15 minutes to go from blank slate to useful episodes. And this would have been quicker if I didn't talk so much. So how long would it take to add another alert source, such as Nagios service alerts? Or maybe SolarWinds alerts. That was easy.
Okay, let's review, shall we? Universal alerting allows us to go from days of implementation time to minutes, getting to that all-important wow moment. And since these universal ITSI components are reusable, adding other alert sources is shockingly quick, especially if you use a TA which already implements universal alerting. If you'd like to explore more, we've got your reference links right here. Everything you need to start using universal alerting in your own environment. Enjoy. And we have an incredible community of Splunk users on our community site. You can search answers. You can continue to the discussion in Tech Talks and find additional resources. And finally, Splunk Ideas allows you to submit new product enhancements or vote for current ideas from other customers. Thank you for your time and your attention.